Hello, hi everyone. My name is Olia, and I lead developer experience at Rootstock Labs. Rootstock is the first and longest running Bitcoin sidechain. What makes Rootstock special is that it is fully EVM compatible. So as a developer, you can write all your smart contracts in Solidity and also enjoy the extensive EVM compatible toolchain. We've created this particular series to walk you through some of the integrations and tooling available to you to make sure that you are fully equipped for building on Bitcoin with Rootstock. In the last episode, we had lovely Anirudh from Gelato. He was taking us through Gelato functions. I hope you enjoyed it. The session was super cool and very informative. And today, we have another guest from Gelato. We had head of DevRel at Gelato, Javier Donoso, and we'll be talking about a different product. We'll be talking about Relay. So first of all, Javier, welcome. Please, would you like to introduce yourself?
Yes, absolutely. Thank you, Olia, for having me here, for having invited to Gelato. We worked in several months with Rootstock. We are very happy. So I will give a short introduction of what we do and what specifically I'm doing with Gelato. So we at Gelato, we started helping developers, and we started helping developers with automation, Web3 functions, and relay or randomness. Now we also have another part of the business, which is rollups. We create blockchains for protocols that want to have their own app chain. But today specifically, I'm coming to talk about Relay. In the developer relations department in Gelato, we try to help our customers with different code snippets, use cases, GitHub repos. So today we're going to go to two of the repos that normally we share with our customers. And I hope that you learn and you enjoy. And in these 45 minutes that we will record the session, you can get up and running with Gelato Relay. So without further ado, should I start presenting already, or you want to say something more?
Absolutely. Now let's jump in and talk about what a relay actually is and what developers can use it for.
Excellent. So this is the Gelato Rootstock Relay workshop. Well, the agenda is we're going to see some use cases. We're going to learn what is Gelato Relay, some security considerations, which is important when we work with smart contracts and with money, and how we can pay, and we will do a workshop. I hope that we have enough time for all of this. I'm Javier Donoso, I'm leading the developer relations at Gelato, and this is my Twitter, the Donoso_if. So, before we go into in detail what is Gelato Relay, we can see here some of the use cases. So you can get an idea what Gelato Relay can provide to your protocol or to the use case that you are building. So basically, Gelato Relay, what it does is allow you to sponsor the transactions of your users. So you as developer, you can offer a better UX in your protocol, allowing the users to interact with Rootstock without having the need to have the native token. So one of the examples is Raya. Raya is a trading chain, and all of the trades, stop losses, swaps, everything is done gaslessly. And we are powering with Gelato Relay all of these transactions. Safe. If you go to Safe and you have some transactions, in most of the chains that Safe is available, they will sponsor your transactions. I think it's 3 or 5 per day. And these transactions are relayed with our Gelato Relay. If we think about Courtyard, if you don't know Courtyard, then it's a marketplace with this vendor machine. All of the interactions that you do here with your tokens, with anything, is powered also by Gelato Relay. Infinix, one of the big players in the space, also creating all of the accounts and doing all of the swaps with Gelato Relay. And besides this, we have Circle, Gnosis Pay, Lida, Everclear, a lot of different big names in Web3 space using Gelato Relay. One of the interesting use cases also that we have for Gelato Relay is the verifier nodes. Some of the chains want to incentivize their users. They allow them to create verifier nodes that test the state at a given point of the chain. And doing this, they will receive rewards. So all of these attestations are sent in the specific case of EduChain with Gelato Relay. It means that even not only for protocols, also for chains, it makes sense to use Gelato Relay, like in this case, that you can create a reward program with verifier nodes powered always with Gelato Relay under the hood. So what is Gelato Relay? Gelato Relay enables users gasless transactions. And as we have seen in the use cases, there is a huge variety of use cases when you can use Gelato Relay. So what is important to know about Gelato Relay? First, that we enable cashless transactions. Second, that we support 20s as payment tokens. We can scale as much as any customer may need. We have had from 1,000 transactions in an hour to 100,000 transactions in a day. We can scale infinitely with our systems. And we have already available on more than 30 networks. How Relay works. So when you use Gelato Relay or any other relayer to send transactions, there are two different things that you have to keep in mind. So this is the flow and normal transaction. This is the flow that is sending a transaction to a smart contract. And here you have the message sender that arrives to the smart contract is the user, and you can send a message.value. So when you use Gelato Relay, these things are not there. And why these two parameters are not there? Because you are sending an HTTP request to the Gelato Relay backend, and the Gelato Relay backend sends the transaction on behalf of the user through the Gelato Relay contract to the smart contract, which is the target contract. So the message.sender is not more the user, but is the Gelato Relay contract. And you cannot send message.value because the user is not sending the transaction from his wallet. In this case, we need, these are two limitations of Gelato Relay, and we have some different ways that we can go around these problems, but we have to be aware of that. So how the transactions are paid, because it's clear that if the user is sending an HTTP request, he's not paying for the transaction. We have here Gelato, which is sending the transaction, and how then the user, the developer, can pay for the transactions. So we have two options. One is off-chain. We have the one balance. It means that you have a kind of gas tank, and every time you send a transaction, it will be deducted, and we will read the exact amount, the transaction fee of this transaction, and we will deduct it from the balance. Or we can also pay for the transaction on-chain. It's what we call sync fee. When you choose for this method, our backend attach the fee collector and the fee amount to the call data, and the target contract reads this amount and transfer during execution to Gelato fee collector. So these are the two ways how you can pay for the transaction. It's much more efficient, the one balance, because we exactly charge the transaction fee from the transaction receipt. But the second one is a little bit less efficient because we have to add a buffer to account for any gas leaks. So
may I just ask a quick question? Sorry.
Sure.
So for the one balance, so yesterday we talked about topping it up for using functions. Would that be the same pot, or is it different?
Exactly. You can use the same one balance for functions, for Relay, and for all of the other services that you may have with us.
Fantastic, thank you.
So the second problem, or the second limitation, is that the user, that the transaction arriving at your smart contract, the message.sender, is not the original user. So how we overcome this? We will use the ERC 2771. And what it does is that we ask the user to sign the payload, not to do the transaction with the native token. We only ask the user to sign the transaction. So this signature will be verified in our backend, and then we attach the address of the original user passed in the request into the call data. So the target contract can decode the original user from the call data, ensuring, because we validate the signature, that the user is this address. So if you have already a contract deployed that you cannot upgrade, probably you won't be easy for you to use this method. You will have to redeploy your contract. But if you are planning to create a contract, thinking about implementing ERC 2771, it could be very helpful because you could use all of these sponsor methods out of the box. So basically, these are the two main limitations on things that we have to be aware when thinking about Gelato Relay. So here we have both methods. What we call the call with sync fee is when we do the payment on chain, and the call with sync fee, we do the payment off chain with authentication. And here is when we sponsor with one balance in both cases, with authentication and with. Two things which are important. In the presentation, I was talking about appending to the call data in the case of the sync fees, the fee collector and the fee amount. And in the case of the authentication, I was talking about appending the wallet of the user. In order to ensure that hackers cannot append call data and then send transactions to your contract, you have to ensure that in these cases, the transactions are only coming from Gelato Relayers, because we can assure that the wallet address will be appended. If you don't check that is the Gelato Relay sending the transactions, someone could append any wallet address that they would like into the call data. And the same for the sync fees. Your code would have to ensure that only the Gelato Relay sync fee contract can send transactions to this method, because if not, someone could also append any address and any amount that they would like, and they could drain the contract. So this is important. Security considerations in Web3, always important, don't forget. So this is the one balance. You already went through this slide yesterday. Basically, is the way we have to pay for the transactions in Relay. Is you deposit in testnet, you deposit on Sepolia, and on mainnet you deposit on Polygon USDC, and it will pay for the transactions for all of the networks where your protocol is deployed, also for Rootstock. So this is part of the one balance. So let's first understand how it looks like when we create an API. So here we have our function. Here we have our app with functions, relay, and one balance. And it's very simple. I go to relay and I create an. I have here all of the information for how many requests I've done, how many requests per minute, if I exceed my plan, if there is a free plan, there is also a paid plan. Here you can see everything. You can also have the analytics, which transactions were made and when, and you can also query this from an API if you need for your internal purposes. So in this case, I would come here and I will say this is, for instance, for testnet. We go to Rootstock, go here, Rootstock testnet. I can decide whether this API key will go for all of the contracts or only for a specific contract. If I click this, then with this API key, I will sponsor all of the contracts and all of the methods, or I can take one contract and only sponsor a method of this contract. I also can tell that this API will forward methods from the safe. So it's also smart enough to understand that we will relay transactions through a safe. So this is how we create the API key. Once it's created, Then we can go here and copy it. I'm not going to show now in the video recording, but it's very easy. So now let me again share my screen. I would like to go straight to the code. So I will share the screen, and probably I will share the whole screen now. So these are the pieces that Raisa will need to cut. Okay, so here we have one of our how-tos on Gelato Relay. There are also some videos out there explaining some of the pieces of the Gelato Relay. And we have here two different contracts. This would be our target contract. Here we will be using the one balance, and as you see, you don't need to change any thing in your contract. Here, as you will see, you will use a sponsored call without any authentication. You don't need to change anything on your contract. In the one balance ERC2771, here we will pay using the one balance, but we need to inherit the ERC2771 context, and simply you have to replace message.sender through this function. What this function does, it only, let's have a look, it only, okay, we cannot, what it does is, if the contract sending this transaction is the Gelato Relay ERC2771, then use the appended wallet address at the last 20 bytes of the call data. If not, use the normal message.sender. So doing this small change, changing message.sender through message.sender underscore message.sender function, you can already use your contract with authentication and relay, only inheriting 2771 contacts. So for the Gelato Relay context for sync fee, so here is a little bit more complicated. We have to inherit the Gelato Relay context. The things that we have to change is, here we say, if it is the Gelato Relay contract, this is one method which is part of the inherited contract. If it's not, then please throw the error. It should be the Gelato Relay. And the only thing that is different is that here we need to add this method, which is transfer the relay fee. And what it does behind the scenes is it takes the fee collector from the call data, takes the fee amount, and transfer to Gelato fee collector. These are the steps that we need to do. And here is the sync fee plus ERC2771. Here we have the 2771 context contract that we need to inherit, and it's exactly the same as before. We will replace message.sender through underscore get message.sender, and we will have to transfer the relay fee. Exactly the same steps that we did before. So we have all of the tests for these contracts. Let's use, for instance, let me see the package.json, the sponsor call. Here, let's have a look what we are doing here. Here we have this contract in Rootstock that I think we can go here and see this is the contract. Sorry, I didn't copy it. Yeah, it's the same. And we have the increment function. So we're going to, first of all, we're going to read from our environment file, the Gelato API key that we created before in the Gelato Relay app. This is how we instantiate the Gelato Relay SDK, and this is normal RPC instantiation, and we get the sign with the private key. You could do for sure this in the UI with normal MetaMask wallet. So we get different information, the user, the ID. We create the call data of this function. That is what we call metadata, meta transactions, because we are sending a transaction within a transaction. So this is the object that we use, the chain ID, the target contract, the data that we just encoded, the user, and then we have here, sorry, this is the sponsor call. ERC2771. The sponsor call without 2771 is this one. So let me use this one. It should be this is the target contract, the counter contract. Perfect. We will do the same as before. Here we have it. So let's have a look what is inside the test sponsor call. Here we will call this contract in Rootstock and we will call the method increment. So first we will need the Gelato Relay API key that we created before in the Relay app. This is our RPC, the designer, and here we instantiate the Gelato Relay, which is the SDK, the Gelato SDK. So we will get some chain ID, and we instantiate the contract, we populate the transaction. Here we will get the call data. This is actually why we call meta transaction, because we have a transaction within a transaction. This is the sponsor call request, the object that we will send with the chain ID, the target, which is the contract that we define, and the data that we created. And then we will instantiate the Gelato SDK. We'll do an HTTP call with this information. So let's do it now. So it shouldn't take that long. This is the chain ID, which is Rootstock. And then here we have our task, our status, the status API. So let's go again to our browser, paste the URL, and we will see that here we have the information about this task. It's already sent to be published on chain, and we are waiting for the confirmation. What is also interesting here is that when we attach the debug data, then we will receive all of the call data from to log number that we need in case that we want to simulate this transaction. It happens sometimes that the transaction fails and you don't know exactly why it happened because it's not a normal transaction. And this actually can help you to simulate the transaction. And in case of Rootstock, as you have tenderly available, so here you would be able to simulate the transaction on tenderly, and then you will be able to check all of the different steps that the transaction is doing and check when it was a mistake. So the second part that I want to show here, we were talking about debugging and doing actually transactions. The second part that I wanted to show is how we can test locally. So testing locally is quite complex when working with Relay because we don't have all of these off-chain components that are sending the transactions on-chain. Then we have prepared this repo where we mock our backend, and you can do all of the tests locally without sending the transactions off-chain. So for instance, we have here this is the contract ERC2771. This is the normal contract that we have seen. But here we are not going to deploy anywhere. We are going to, we're going to work with our Hardcat node, and we point this node to the Rootstock RPC, and we will do some tests. And we will see that all of the tests are passing, and we can go one by one and understand what is happening. So we have here tests which are passing, and let's have a look in the counter ERC2771. Is this one, this contract? And let's see how we are mocking the test locally. So this is our first test, nothing new. We are using test. We are getting the deployer from designers. We are deploying our contract. We are instantiating the counter contract. We have the deployer address. This is of the test. What is important here is that we calculate the call data like we did before, and we prepare the request, and we send the transaction, but we use this called local request. So what we do here is in this local request, we encode the address of the user the same way as our backend does, and then we send the transaction locally. So what you receive here, you do when you do this, actually, we are doing two things. We are attaching the call data as our backend does normally to the request, and then we are sending the transaction. So in this case, the contract, when calling the underscore mesh as .sender, will receive the correct sender, which is the original user, and then we can continue with the same, with the logic of the contract. The same for fee collector and relay context. Exactly the same. This is the same. We are using the same methods as before. We are instantiating the fee token address, which is a mock ERC in this case. We are instantiating the contract, the target contract. We do some tests like set balance for the counter address. So the same again, we prepare the call data. We prepare the request like we would do when we send the transactions on chain, but here we will call the call with sync fee log. Have a look. What we do here is we encode with sync fee. And what does it mean? It means that we are encoding the request. And we are encoding the request, adding the fee token and the fee collector. And these are two different methods. So remember when we were talking about sync fee, on chain, we read the fee token and the fee to be paid to Gelato, and this is how actually we build it in our backend. We attach this call data to the original call data of the transaction, of the request. So this will be the relay context, and the relay context ERC 2771 is having both encoding the fee token plus the address at the end of the call data. Here we can see this is the mock call. Here we have the call with sync fee 771, and we are passing the user, and then we are encoding the fee collector, and then afterwards we are encoding again the Solidity, the address of the user. So basically, this is how it works. If we have a look now in our contract, this is the contract that we send the request. We will see that in the internal transactions, we must have exactly this is the one that we were sending. We don't see in the normal transactions tab because it's not a transaction that this contract receives directly. This transaction goes through the Gelato Relay contract. That's why you will see it in the internal transaction. This is something that sometimes the users are asking us. I don't see the transaction. Yes, it is there and it is in the internal transaction tab. So it did work. If we go to the Gelato Relay API without the debug part, we will see that the transaction was executed, and this is a transaction hash. Oops, still exactly. It was still in the. Here we can see the execution was successfully. So basically, that was all of the things that I prepared for the presentation. And if you have questions, happy to answer, or happy to go in detail in some of the parts that we saw.
Yes, thanks so much. Really enjoyed it. Great presentation. I think in terms of if you could still share, we quickly looked at the analytics. I was wondering if you could maybe share the screen again and take us through what analytics a user can expect and how that is useful.
Yeah, sure. Indeed. So we have here our relay dashboard, and when you work with Relay, you have different plans. Here is, for instance, the plan for Relay. You have in the free plan 1,000 requests per month and 1 request per minute. And this is the gas premium fee that we add on top of the transaction cost. So if you have another plan, if you need more requests per month or more throughput, then you upgrade and depending on your needs, and you can even have an enterprise plan if needed. For users with a lot of demand, they require to have know exactly where they are, because if you think that you're going to be rate limited or your transactions are not going to go through, then you need to know exactly what is your where are you spending your request, which API keys are maybe causing problems. So that's why here we have the dashboard with the main information, and then we can go through analytics. And you can, for instance, select all of your different apps that you have. In this case, I'm only use the workshop one. The states, was a successful transaction, was a cancelled request, was it an invalid request, and on which networks do you want? You also have the overages. It can, in the paid plans, although you have achieved your quota, you can scale with auto scale. Here you will see when you went over the throughput limit or the monthly limit, so that you understand that maybe it's better to have a bigger plan and not pay for auto scale, which is expensive. So, and here you will see the requests for the apps and the networks, depending on the status of the request, whether it's successful or failed or cancelled. Cancel, it means that after 5 retries, if it doesn't, if it's not successful, it will revert. This is probably the same, but for the apps. Yeah, this is globally, well, for the different status. So all of the information that you can see in the analytics, and also you can also call to an API, because in some cases you may need different type of granularity. So if you want to create your own dashboard with, you can also automatically create or remove API keys. Then with SEWE authentication, you can create, remove, or query the different usage or transactions or API keys that you need.
Oh, thank you. Thanks so much. I also normally ask about use cases, but in today's case, we started with use cases, and I think it's one of the most clear probably use case in the whole building within the Web3 is because it's difficult to onboard users, and obviously Relay lets you simplify that process, and we talk about it a lot. So I'm not going to go there. However, I also wanted to ask you, at some point you mentioned that we were looking, I think, at the Explorer, and you said that sometimes the users can't see the transaction, which is kind of sounds like a bit of a common pitfall. So I was wondering if there is if you can maybe name a few other kind of frequent mistakes, or also if there's a log or like an FAQ section that people can explore before they, start panicking that nothing's working.
Yeah, good point. Actually, it's one of the things that we have in our to-do is to expose the FAQ that we use internally. When we have a new dev joining the team, we have a lot of questions that should support to get speed up and running, helping the customers. But we haven't them exposed in our documentation, and it would actually make sense because it's like debugging with Tenderly that normally works. Believe me, it is in the docs. It's in a very small part of the docs, and no one actually read it. And it's one of the classical questions: why my transaction is not working, and I receive no error selector? What did that mean? This normally means that is reverting in your custom in your contract because of your custom logic. So it's not part of it's not reverting in our end. And the way to debug this is create the call data and call the Tenderly link, or in the case that in your network, which is not the case of Rootstock, then you can with Foundry simulate the transaction. This is a normal, one of the questions always asked is why I cannot pay for the transactions with ETH in my wallet. I want to that the users pay with ETH on their wallets. This is not possible because you don't have any. Actually, this is why EVM compatible chains are so secure, because you cannot go to a wallet of someone and take the ETH. So that's not feasible. However,
yeah, not a bad thing, let's say.
Exactly. But the alternative that you have there is to use, you can pay with sync fee. Remember that we are transferring to the Gelato fee collector, and you can pay with different tokens. You could pay with USDC. So if you, in your contract, implement signature decoding, you could, with permit, sign the transfer of USDC from your wallet to someone else. So the only way to extract with Relay some tokens, not native tokens, but for instance, USDC from the wallet, from a user's wallet, is using the permit function on the contract, on the token contract. If they don't have a permit function, you cannot do this. But this is one of the common use cases. I want to transfer USDC using Relay. And we see more and more that people tend to have 20s when they go to a chain because they breach but they are always reluctant to breach the native token, because maybe they don't see the utility. They think that maybe, I don't know, I have to withdraw afterwards. But they have USDC or USDT or Bitcoin. And these are the tokens that with permit function, in the case that is available, you can use it for paying for the transaction. These are the classical questions, plus the one that we already answered at the beginning. The message.sender is not my user. Yeah, it's not your user because it's the contract that we are using to forward your request.
Fantastic. Thank you. Well, that was very insightful. All right, so I want you to keep you for much longer. My last question to you is perhaps, and again, you're leading a developer relations team, so I'm sure you've answered that plenty of times. Is your advice for somebody who's just getting started with Gelato, with implementing Relay?
I would say use the sponsor call, because you don't need to implement the sync fee methods in your contract. So it's very simple and it should be very straightforward. Import the SDK, install the SDK, call the sponsor call in your contract, and you will see the transaction executed. And when you get the task ID, you see that is waiting for the confirmation, is execute success. You have your first wow effect because something was happening without sending the transaction directly, and then you can move from there. We have for sure videos and documentation and repos. But I always say you should be hands-on in this business. Do it, implement it, even with half an hour coding, and try it.
Yes, fabulous. I love this. It's normally the shorter time to a wow effect, and we're there, right? And then you can
exactly.
so start simple and then build upon it. Oh, fab, fantastic. Well, Javier, thanks so much for joining us. I had a great time watching your presentation, learned a fair bit. So I hope the viewers also have enjoyed and that it was useful. And as always, I'd like to say to our viewers, do join Gelato's community on Discord. As we've discussed, if you have any questions, the team are there to help you out. And if you haven't done yet so, do join the Rootstock community as well. We've got a bunch of friendly fellow developers there talking about all sorts of interesting projects they're building, and we'd love to see you there. So thanks again for watching. Happy building. We'll see you soon.